Okay, the record is now on. So this is the floor plan. Please refer to this floor plan because I think I use this plan for students at SIIT as well, and they sort of refer to this plan all the time. You know, the plan for the concrete structure. Now we are using this plan to design the steel structure. Keep that in mind. So, okay, this is the second floor plan. Let's just look at the columns first. Okay, now you can see that we have typically 2 columns. So if I mark this, I can just call this maybe say C1. Hang on a minute. Okay. Just a minute. Okay. So from this, we can group this. You know, every column as a C1. Okay. Now, because this load may not be very big, and be mindful that some column will have the wall coming in like that, some won't. So when you look at all the columns in this pink cycle, you take the most critical one and design for it. Okay, so that covers C1, and here load here shall not be much different from C1. So you can use C1 for the matter. Okay, so that means this is also C1. This is also C1. Now keep in mind that this will have the heavy wall coming in as well. So when you include the wall here and here, the load may not be different from say this C1. Okay, so you pick the most critical one out of this grid core and then design for the column section. Okay, one would do. Now we move on to the next. Okay, it's going to be this one. Okay. Generally, when you look at this, you can say that this is going to be your C2. Okay. So in the similar fashion, you try to figure the most critical one and design for it. Okay. And let us go back to the tributary area of these 2 columns. You can see the C1 is that one. It's just a half of 6 meters and then the bay of 4.5 meters in the horizontal direction. Okay. So here is a half of 6, so that's 3. And then that's a 4.5. So that becomes your tributary area. And for C2, this is a half of 6, and then plus the entire area of the corridor. Okay. And then the width here is 4.5 meters. So that is the area, the tributary area of C1 and C2. So when you pick them up, okay. Now you try to pick the most critical one for C2 by considering the wall. Okay, there are 2 ways to include the wall load. I think I must have put the wall load in the description for the design phase 4 already. The first one, but let's repeat it here. The first one, just to direct calculation. Oops. Meaning, let's say for this column, for example, okay, in grid number 5, you see that its tributary width or area, I mean, will be half here, right? And then half here. So that becomes the tributary width of your column C2. All right, let's put some perspective on it so that you can see. So when that becomes the tributary area, you may account for the wall. Oops, I'm sorry, it's the wrong button. You may account for the wall right away that, okay, the wall in this area is just this long, that long, and then that. So you calculate the wall directly and then add it to the load of the column. See, account for walls in tributary area. Okay, the second is, say, the average calculation. Now, the second one would work when we have a structure with the strong floor, such as the high-rise building, the condominium, where they use the precast concrete structure, the pre-stressed concrete, the post-tension floor for the entire floor. In that case, generally, the walls will be all over the place, according to architectural design. And because we don't have beams to support anything in the post-tension concrete, what we do in design is that we would try to find the wall load, account for the weight of the wall over the area, and then turn that into the superimposed load on the floor. Okay, so that would be superimposed uniform load on the floor right away. The second one will not be the second one that I just mentioned here. This is the more suitable if you are dealing with the strong floor, such as a post-tension pre-stressed concrete or the flat slab, and you're going to enjoy that if you can turn all the wall load into the uniform load on the floor, because you would not care anymore how the architects would move the wall. But for a small structure like this, we always need to provide the beam to support the floor, the walls. So in this case, it would be more convenient for us to just account for the wall here and then just put them directly on the column. Okay, and for C1, you're going to have this, right, for the wall. Yeah, half of this and then half of that, and at the corner you have of that. Okay, and for C2, you just pick the most critical loading condition and design for one column. Okay, one for C2, one for C1, and then you may want to have a quick check on this one and see if you need C1 or C2, okay, by doing a quick load summation. And this one, it's kind of small load. You see the area is very small load. So that means you may use C1, okay, because I've seen the load for C1, it's pretty small. So perhaps the column section that you will use for C1 is already small and you cannot go smaller. And this is just like a 6 column. So we don't bother to maybe order another size for it. Okay. And don't forget that, don't forget roof. Okay. Don't forget roof. Okay. So that's going to cover the column. Any question? And I would like you to also draw the column load diagram, because that's what's going to be given in your exam. Okay. Now, yeah, this is we already mentioned the column load diagram. It's going to look like that. Okay, try to draw. Let me go back to that page and so that things are in the same page. Okay. Try to draw column load diagram. So it is going to look like this. This is your column. Okay, and that's your roof. You don't have to draw a truss, just say maybe roof, that's enough. And then you know that there's a load coming in from the roof, right? And then you have the second floor here. So then there will be a load coming in from the second floor. So this part of the column, this part carries the roof, right? And this part carry roof plus second floor. And as I have mentioned before, that generally we change the column section every 2 floors, but that's all we have because we're gonna reach the ground soon. So that means we can use a 1 column section for it. Okay, and I think it's pretty obvious that this is the critical section, right? So you design the column with that side and just use the same side up to the roof. Okay, and I think you design the 2 sizes that will be sufficient, 2 sections. Okay, and please feel free to use the design table that are given to you in the class, the table number 1, number 2, or table A or table B. You have your unbraced length. Now you can assume that this is going to be pin, and I don't know the support condition we are going to use. You may assume pin. If it becomes fixed, you get the benefit. All right. So let's try to use a pin assumption for that. Okay. So is there any question about the column design? I think I have covered everything. In the end, you should, to be a good engineer, you must provide a complete package. That is the drawing with the column numbers for every column. Okay. Any question? Well, if there isn't any, I should have made like 2 copies for this. So let me do that. Yeah. Copy page, and then I can just add another one here. Yeah, that's how we do it. Okay, so we're gonna move on to the beams now. Okay. Now the beams, I think we can design for 3 sides of the beam, I suppose. Okay, so we are going to begin with the typical ones. Now you know that you are going to have the beam here. Okay. Pin would be better, maybe. Here, 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 here. Okay. Now this is typically, I think we can categorize this into the same group simply because they have the same span length. And all these beams are horizontally braced by the floor. So you need to check the loading conditions first, right? See how different they are, because the span length are the same. So the difference in moment will be caused by the difference in loading. So you probably have 3 loading conditions that as far as I can see, okay, in grid 1, where you have half the floor plus the wall Okay, that's probably number one. And then number two here, just full floor. And number three here, where you have a full floor plus the wall. Okay, so I am not sure what you're gonna get, but I reckon that you probably need two sides. For it. Don't forget that when you design the beam, you must check for flexure, and flexure you have local buckling and the design moment, the nominal moment. Okay, shear, where you have to also check your local buckling and the shear capacity of your beam, and deflection. Okay, we don't have the specific criteria for it, so I think you're free to choose whatever you want. Okay, now, is there any question about this? I believe we all know that when I talk about the floor, you already know that, okay, the floor goes in this direction, right? Nobody use any different, say, direction for the floor. So let's say this is the first case, half floor, that's it. Okay, the second case, this is the second one. Okay, and then the third one, let's use a different color. This. Okay, so you probably need two beam sizes for it. And that's the first one. Okay, now we move on to when you look at this. Now what you need here is that you're going to put the floor in this direction as well, I suppose. Let's make your life easier. Okay, maybe I should use the blue to differentiate this. Okay, that's better. Oops, got that as well. So, geez. Now, when you put the floor in this direction, generally what you need, if you can still recall the structural analysis, you need this to be either the cantilever, so that when you look at this beam, this is your free body diagram of the beam, correct? Okay, and with the uniform load acting on it. And now you see that because we put the floor on this cantilever portion, so the burden is not much. But you see, in reality, when you have a structure like this, you must have a beam here. It doesn't matter if it doesn't carry anything. Okay? You cannot leave it just open like that. So you're going to need the beams here. Okay? Then this. Now, this beam, when you look at the floor, it should not support anything except one who is very thorough in details, and you spot that they have the sort of a concrete or whatever, you know, the bench around here. So let's talk about this a little bit. Now, let's say you can include this, or you can say that the bench will be made of wood and it's going to be very light. You may include bench, up to you, or you can or say it's negligible. Okay, because you're going to use wood, or you're going to use steel, or, you know, say maybe movable bench or whatever. So you end up having a structure like this. And now you can see, we don't have the, let's compare this one, this beam to this beam. Okay, this one is a simple beam. So when you see a simple beam like this, I hope that this is still in your mind, the structural analysis. Okay, so this is let's do a better job here. This is this, then this is this. Now this case with Roman numeral number 1 here will give you the greater moment, right? Because this is this moment is going to be WL squared over 8. Meanwhile, when you have the cantilever, the presence of the negative moment will reduce the positive moment in the case, the Roman numeral number 2 here. Correct? Because this negative moment, let's say the negative moment will reduce the positive moment in midspan. Okay, but the negative moment is there, so you have to check it just to make sure that it's not greater than that, and by that reason we can use the same beam. Okay, because you know, a simple beam somehow becomes a more critical, and in this case we're not going to create the continuous beam without necessary, so we can do 2 simple beams here. So that means this becomes a more critical one as well, so you don't have to worry about the cantilever portion. Okay, and for these beams, because it doesn't carry anything except the bench, which we may use the light material, you can just put any beam size in there. Okay, now is there any question about this? All quiet. All right, so that's the first one. The second one, when you consider the staircase, because this is a new set of span length, correct? Now it's only 3 meters, and you may see that okay, this is going to be your most critical one, simply looking at the area. Okay, because the tributary width for this one is just similar to a beam number 2 that we just mentioned, right? So let me use the blue one. That becomes the tributary width of this beam. Okay, so you can just check this one, and you can assume that we can either use the because if this is a steel building, it's very sensible to use the steel stairs or wooden stairs, and they are generally very light. So you may assume the steel or wooden stairs. The live load is going to be the same, and the date load here, say if you wish to calculate, I'd say about 100. Date load about 100 would do. Don't take my number for it. Just okay, I think that should be good enough. Generally should be lighter than that. Okay, and then you have the you may check the moment here and use the same sections, but I think you should use the different section because it's 2 times shorter. So when you let's say W is the same, moment is going to be 4 times smaller, correct? Say WL squared over 8, they are also WL squared over 8. If W is the same, your length is 2 times shorter, so your moment is 4 times shorter. So this is probably the another size for your beam. And when you check this one, which is the most critical, you can use that for this. But or you may, because when you look at this beam, this has to support this beam coming in, right? But this beam doesn't carry much of anything, so you can also calculate this or this, you know. Check this, either this or this, and then this one, you know, it's half, and the wall and the stairs pretty light, but it carries the wall. So, you know, I think it's just pretty much the same way. And you may, if you want, there's another stuff here, okay? Another one is this one. It's longer, and it should not be part of the frame. But this one, you know, you may wait for it, because this should be considered along with other beams here in this direction. But these beams, you know, all these beams in the horizontal direction. This one, I don't want to, you know, paint everything. And that one, and then that one, there is no floor on it. So I have to say that these beams, okay, these beams, oh my, run into that, sheer luck. Okay. These beams are not laterally braced, and that means you cannot design for it just yet. Okay, it may become a part of the next phase of your design with Advanced Touch, because it's going to be part of the frame as well. So in a nutshell, let me summarize that. For this part of the beam now, you should check all the different loading conditions with these beams here, which you may have 3 conditions. When you calculate and you see the moment, you see that perhaps you only need 2 sections for the beam, not all 3 of them, okay? And then you can move on. You can also use the same section for this cantilever portion, but you need to check the negative moment, that they don't exceed the positive moment here, and then you can use the same section. There are, I forgot to say that there are 2 ways to do this. You can design this, but in steel structure, you see, if you really want to have an overhanging beam like this, it means that you must provide the continuity here at the support, right? That's in the real world. You can draw this overhanging beam on paper, and then, okay, now I have a whole overhanging beam. Yes, you can, and then you do the simple analysis. But in the real world, if you want this, it means that this is continuous, right? Because the moment here is equal and opposite in both directions. So it means that when it comes down to construction, you must provide details so that your beam is going to behave like this. So sometimes it can be tough, and then you may end up designing the beam that you know, that's your column, and then your beam stops here. And then you just design this as a cantilever beam. But again, regardless of the details that you may use, because you don't know how just yet, using this design approach will be good enough, because you check the negative moment. So if it's a standalone, it should survive. Okay. And if you design this as a simple beam, that will behave as a simple beam inside. And so this will be similar to that. Okay. So that will cover this area. And this, and now you move on to this, and you just maybe check the 3 of them and just use one side. Okay, and but I suggest that maybe check this would be enough. If you say this is just the wall, okay. So my guess is that it should be closed, but if you can include the calculation to verify this, it will be really work on your case. Okay, so then that's it. So roughly 2 columns, 3 beams, that would do. Any question, please? Question, please. Hey, that's it for me. If you don't have any question.
Maybe question will come
Half a day. Okay, go ahead.
Maybe question will come later.
When? And I wish that you would post your questions on the Facebook group, because everybody can see the answer. But let me pause the record.